Okay, so we'll be discussing the Statistic 1 paper for May-June 2023, paper 5-2. Okay, so we'll start with question number 1. Okay, we are having the random variable x, and there are three values for the x are -2, 2, and also 3. And then it is given that the probability for x to the particular value is k x squared minus 1. So where k is a constant, draw a probability distribution for x given the probability of as numerical fraction. Okay, so before you can draw our probability distribution table, right, we actually need to find the value for k first. Okay, so to find the value of k, we need to know that when we try to add all the probability together, right, the total of the probability should be equals to 1. Okay, so that means now you should try to find out the probability for every single value of x. So first, I am having x equals to -2. Substitute it into our function here for the probability. So -2 square, you have a 4, right? So 4 minus 1, you get a 3. And then you're having 3k. So the first probability for x equals to -2, it is 3k. And then plus, now I want to substitute the second value for the x, which is a 2. Substitute the 2 in this part, so you're having 2 square minus 1, which is a 3 also. So you're having the second probability, which is also a 3k. And after that, you substitute x equals to 3 into the probability equation. So you're having 3 square, 9, 9 minus 1, you get an 8. So you're having 8k for the third probability. Okay, so these are the probability for the three value of x here, and total of this probability should be equals to 1. So I'm having equals to 1 here. And after that, I try to find the value for k. So the value for k is actually 1 over 14. Okay, so after I found the value for k, then only I start to draw the probability distribution table. It will be a table with two rows. And then the first row will be, will show the value of x. Okay, so first one is the value of x. And the second one, we are showing the probability, the value of the probability. Okay, so I'm having this x equals to x. Okay, so I'm having three values for x here, right? -2, 2, and also a 3. So I will just put it as -2, and then 2, and also the value 3. And after that, I want to substitute in the probability here. Okay, so like what I calculate just now, right? The value for the probability for first value x, -2, is 3k. So I already get a value for k, which is 1 over 14. So I multiply 3 with the 1 over 14. So the probability for -2 is 3 over 14. Same thing happened for the second value x equals to 2. The probability also is also 3k. So I'm having also 3 over 14. And after that, for the third value, the probability is 8k. Okay, so 8 multiplied with 1 over 14, then you should have 8 over 14. Okay, so this is how we show our probability in the probability distribution table. Okay, all right. So before we can draw, of course, we need to find the k first. Okay, so this is our first question, the first part, and after that we proceed to the second part. Okay, so for the second part, they want us to find the expected value for x and also the variance x. Okay, so for your information, to find the expected value of x, right, the formula is the summation of x multiplied with p. So that means according to the table that you draw just now, to find out the expected value for x, you need to take x multiplied with p. So as an example, the first value of x is -2. You have to multiply with the p, the probability here. So I'm having -2 multiplied with 3 over 14. And then you add, summation means add, right? And then after that, you try to continue it with the second value. So second value is a 2 multiplied with the probability also. So I'm having 2 and then 3 over 14. And then we do the same thing for the third value. So 3 multiplied with 8 over 14. Okay, so from here we will get the expected value by just pressing the calculator. Okay, if you didn't do any careless mistake, your answer should be 12 over 7. Alright, so this is the expected value for x that we have. Okay, then now we want to get the value for variance x. Okay, so before you can get the value for variance x, right, I need one value first, which is expected value of x squared. So for the expected value of x squared, the general formula is you want to take the summation of x squared multiply with the p. Okay, so you take x squared multiply with p first, and then you add them together. So this is our expected value for x squared, and we need to use this later to get the value for variance x, right? Okay, so for the value for x squared, that means you need to square the x, then only you multiply it with the p. So if I write out the step, I'm having -2, which is the x, I square it first, then multiply with the p. Same thing happen for the rest. Okay, and then by right, you should get a fraction also, which is 48/7. Okay, and we haven't complete yet. Next, we want to find the variance. Okay, so to find the variance, there's a general formula also for variance. Okay, so variance will be ex squared, expected value for x squared, minus the mean square. So this is a general formula for the variance x. Okay, so since I already found the expected value for x squared just now, right, which is 48/7, then minus the mean. The mean also I got it just now, which is 12/7, and then I want to square it. Okay, so if you didn't do any careless mistake, the value for the variance should be 192/49. So I will keep it in a fraction form. Of course, if you want, you can change it become 3 significant figure. Okay, so this is how we answer question number 1. Okay, so we come to question number 2. All right, so there's a sport event taking place for 4 days, beginning on Sunday. Sunday will be the first day actually. And then they are telling us that on Sunday, probability it will rain is 0.4, not raining will be 0.6, all right. Okay, on any subsequent day, the probability that it will rain is 0.7 if it rained on the previous day. And then 0.2 if it did not rain on the previous day. Okay, so for this one, right, if you want to draw a tree diagram for 4 different days, it will be very, very big, the tree diagram. So to avoid confusion, what we will do is that we just try to draw a simple one where I'm having the tree diagram for today and also for tomorrow. Tomorrow. Okay, let's say for today, I might have 2 possible results, right? I can have rain or not raining. Okay, after that, for tomorrow, I might have rain and not raining. And then this one is rain and not raining. Okay, so from here, basically you need to know, if today is raining, then tomorrow is raining also, the probability will be 0.7. If today is not raining, then tomorrow raining, the probability will be 0.2. So this will be 0.8 and this will be 0.3. Okay, and then the probability here, it depends on which is the day that you have. Like if let's say you're having Sunday, right, probability of raining will be 0.4. The probability of not raining will be 0.6. Okay, if let's say the today here is a Sunday, then basically this is a probability. Okay, if today is not a Sunday, that means you just need to refer back to what we have here. Okay, what is the probability that you have on that particular day? Okay, Alright, so maybe we can try to use this simple tree diagram, okay, to help us to write out the step correctly first. Okay, so first of all, they want us to find the probability that it does not rain on any of the 4 days. So if that does not rain on any of the 4 days, right? Basically, it's like this. So first day not raining, second day not raining, third day not raining, fourth day also not raining. Okay, so for first day not raining, right? Sunday one, the probability of not raining is 0.6. Okay, so then we come to second day. So second day, on this second day, okay, so maybe I shouldn't write today and tomorrow, I should write previous is better. Previous day, and then today. So today means, okay, on this particular day. Alright, so on second day, which is the today, I want to get the probability of not raining. So which one is the probability that I should take it? So you have to ask yourself, previous day, is it rain or not? So previous day not raining, right? If previous day not raining, today also not raining, the probability is 0.8. Okay, so I'm having 0.8 for the second day. Alright, then when you come to third day again, so you ask yourself, if third day is today, right? Previous day, is it raining or not? Not raining also, right? If previous day not raining, today today also not raining, so the probability is still the same, which is 0.8. Okay, then the same thing happened for the 4th day because previous day not raining, today also not raining, the probability is 0.8. So I'm having 0.6 multiplied with 0.8, 0.8 and 0.8. So from here, I'll get 192 over 625. Usually for me, I will keep my answer in the fraction form if possible. Right, this will be the most accurate answer that we can get. Okay, all right, so this is what we have for part 1, part A. Okay, then now we'll want to continue to part number 2. Okay, let's have a look for part B. Okay, so for part B. Okay, all right, so for part B, I will still refer to the same tree diagram here. Okay, let's say now, find the probability that first day that it rains is Tuesday. Okay, so that means the event start on Sunday, right? So that means Sunday not raining, then Monday also not raining, then Tuesday only it rain. So the fourth day, whether it rains or not, it is not important anymore because you only want to focus until the Tuesday only. So that means the first raining day is on Tuesday. So I have a tick on the third day here. Okay, so again, for the very first value, it is Sunday, right? So Sunday not raining, probability is 0.6. Okay, correct. So Sunday not raining, the probability is 0.6. Now I come to the second day. So my previous day is not raining. Then today also not raining. What's the probability? So previous day not raining, today also not raining. The probability is 0.8. Okay, then now I come to the third day. So for the third day, right? Previous day not raining, but today it rains. So previous day not raining, but today it rains. It will be this one, which is 0.2. All right. So if we try to calculate the probability, it should be 1,2 over 125. Yeah, right. Then now let's proceed to the third part. So before we go to the part C, I need to copy this diagram first. Okay, so we go to part number C. Okay, so for part number C, okay, so for part number C, let me bring this up. Okay, so part C. So for part C now, they want us to find the probability that it rains on exactly one of the 4 days of event. So what are the possible results that I have? One of the 4 days of the event. So that means I might have a few different cases. Maybe I have first day raining, the remaining days not raining. So this is the first case. Second case is I might have first day not raining, but only the second day raining. Okay, then the third one will be third day raining only. And the last one will be the fourth day raining only. Okay, all right, so you need to write out the probability slowly. Okay, so now first day, like what I said, first day is Sunday, right? So Sunday, the raining probability is 0.4, right? If I'm not mistaken, it should be 0.4. You can read the question again. It should be 0.4. Sunday raining. Okay, then now I come to the second day. For the second day, right, it is not raining, but the previous day is rain. So if previous day raining, but today not raining, what is the probability that I should put in? I should put in a 0.3. Okay, then now I come to the third day. So when I come to the third day, right, my previous day is not raining. Third day, today also not raining. Previous day not raining, today also not raining. The probability is 0.8. Okay, then after that, when I come to the fourth day, previous day not raining, today also not raining. So previous day not raining, today also not raining, it will be 0.8. Okay, so this is the first result that we have. And then you can try to simplify them first. By multiplying all these probability together, you should have 48 over 625. This is the first case. Okay, then now we go to the second case. Okay, so for the second case, Sunday not raining. So the probability that Sunday not raining is 0.6. First day not raining, so it has a special probability which is 0.6. Okay, then now I come to the second day, which is today. The second day is today. So today raining, but previous day not raining. So you go and ask yourself, okay, previous day not raining, but today raining, the probability will be 0.2. So you put a 0.2 here. Okay, then after that you cancel out. Then now you come to the third day. So for this third day, right, the third day is today. So today not raining, but previous day is raining. Okay, so you have a look for the tree diagram again. Previous day raining, but today not raining. So it should be 0.3. So you put in 0.3 here for the second case. And the last one is previous day not raining, then today not raining. Okay, so previous day not raining, today also not raining. If you have a look for the diagram, it should be this one, which is 0.8. Alright, so you're having 0.6 times 0.2 times 0.3 times 0.8. Okay, 18 over 625. Alright, so if you understand what am I doing here, basically you can maybe pause this video for a while and then you try to write out the probability for the other two cases and see whether you understand it clearly or not. Alright, okay, then now we proceed to the third case. Okay, so for the third case, first day is Sunday, not raining. So not raining on Sunday will be 0.6. Then for the second day is today, today not raining and previous day not raining. Previous day not raining, today not raining, the probability is 0.8. Okay, then when you go to the third day, is today, today raining, previous day not raining. That means previous day not raining, but today rain. Wait. So previous day not raining, but today rain. The probability is 0.2. Okay, then until the fourth day is today. Today not raining, but previous day raining. Okay, so previous day raining, but today not raining. The probability is 0.3. So I'm having 0.3 here. Okay, then after that you can try to simplify it out, of course. Okay, then you should get also 18 over 625. 18 over 625. Okay, then we come to the last case here. First day, which is a Sunday, not raining. So the probability will be 0.6. Then second day is today. Today not raining, previous day also not raining. Previous day and today not raining, probability is 0.8. Okay, come to the third day is today. Today not raining, previous day also not raining. It is still the same, which is 0.8. And lastly, the fourth day is today. Today raining, but previous day not raining. So previous day not raining, today raining, the probability is 0.2. Alright, so again, you try to simplify all your value here. Okay, by right, you should get 48 over 625. Okay, so now I want to get the total probability lah, because we are having 4 different cases here and find them out separately. So what is the total probability now? The total probability will be, you add all the cases together, the probability together. So 48 over 625 plus 18 divided by 625 and so on. Okay, so by right, if you didn't do any careless mistake, right, the answer should be 132 over 625. Okay, or if you want, you can change it become 3 significant figure answer, which is 0.211. Okay, so this is how we solve this question number 2. Okay, so question number 3, we are having a back-to-back stem plot. We present the monthly salaries in dollar of 27 employees from 2 company A and B. So these are the salaries and monthly salary. And then if you have a look for the key here, 271,276. 271 means $2,710 for the company A. And this is for company B. Okay, then now they want us to find the median and the interquartile range for the monthly salary of company A. Okay, so to calculate the median, it will be the center location of these 27 values. Okay, so where is the center or the middle of this 27 value? It will be, when you divide 27 or 26 by 2, it will be 13, right? So the 14th number in company A will be the median. Okay, so you need to count the 14th number lah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so our 14 will be this particular value, which is 2710. So they are talking about salary here, right? So usually I will encourage students to write in the unit if can. So you write in dollar and then 2710. This is your median. Okay, so after you get the median, before you can get the IQR, the interquartile range, you need to find out Q1 and Q3 first. So what's my lower quartile? Okay, since just now we already know that this one is the median, right? Therefore, to calculate the upper or lower quartile, I will ignore the one here. Okay, so the first half of the set of data is all this. And just now you know that this is the 14 value, right? 14 number, which is a median. So the first half set of the data is 13 value. Okay, so I'm having 13 values here. 13 values. Where's the median for these 13 values? Okay, so 12 divided by 2, I have a 6, right? Therefore, the middle value will be the 7 value for this first the first half set of the 13 values. So the 7 value will be the median. So the median for the first half set of data will be the Q1. Okay, so my Q1 will be the 7 value where I start to count again. Okay, so if I try to count again, 1, 2, 3, 4, 5, 6, 7. So this particular value here will be our Q1, which is 62610. Now, next one, I want to find the Q3. So the simply happen, Q3 will be the median for the second half of data. Second half of data, I also have 13 values, and my median will be at the 7 number. So I also count 7 number from the median. So 1, this is a 1, 1, 2, 3, 4, 5, 6, 7. So the 7 will be this value, which is 2840. So my third quartile will be 2840. So the 2840 actually is the median for the second half of the data, and it actually denotes the upper quartile. Alright, so after I find out median, find out Q1 and Q3, then now I can find the value for IQR very easily. So I'm having 2840, then minus 2610. Therefore, my interquartile range will be 230. Okay, so this is how we decide the value for median, Q1, and also Q3. Okay, alright, so let's proceed to part B. So for part B, they want us to draw 2 box and whisker plots. Okay, in a single diagram to represent the information for the salaries of employees at company A and B. Okay, so first of all, before we can draw the box and whisker plot, right, I need 5 values here. I need the minimum value, I need the Q1, I need the value for median or Q2, I need the Q3, and also I need the maximum value. Okay, then I need to list it out for company A and also company B because we're having 2 companies here, right? Okay, so for company A, what is the lowest salary? So for company A, lowest salary is 2,500. Okay, so if I write out 2,500. Then Q1, Q2, and Q3 we already get the value just now, right? Q1, 2610. Median is Q2 and then Q3. Okay, so the 3 values that we get just now is this one, 2610. Q2 is median, 2710. Q3 is 2840. And what's the maximum salary for the company A? So maximum salary is 3010. Okay, so 3010. Then now we look for the company B. So for company B, they already give us all the Q1, Q2, and Q3, right? So you just apply it straight away. Okay, but of course I still need the maximum and minimum for company B. Minimum for company B is 2540. Maximum is 3090. Okay, so minimum is 2540. Then the maximum is 3090. Okay, then now by looking at all this value here, this is a minimum value and this is a maximum value, we try to squeeze everything in a single diagram. So they have to share the same ratio or same scale for the x-axis. Yeah, right. So I will start drawing now. my smallest value is 2,500, the largest value is 3,100. I assume 3,100. Therefore, when you want to sketch a diagram, you should start from 2,500 first. Okay, so maybe I'll make this one as 2,500, and then 2,600 is this one. Should be enough to get 3,100, right? Okay, and then of course, when you try to decide the scale and everything already, don't forget to label the axis clearly. So they are talking about the monthly salaries, and then this one, the unit is in dollar. Yeah. All right. So after you settle up everything, then you can start drawing the tree diagram. Sorry, not the tree diagram, the box and whisker plot. So we start with company A first. 2,500 is the minimum. So you're having minimum 2,500. Okay, then 2,610 is the first quartile. So you can draw it like this. Second quartile is 2,710. So 2,710 should be somewhere here. So you can see that I'm using a ratio that's quite easy to measure. So when you draw it, it will be, it is not something hard, okay? If you decide the correct ratio. So 2,840 will be this one. And after that, the maximum value is 3,010. So 3,010 is this. Okay, so the middle three line, the Q1, Q2, and Q3, we need to connect it by using two horizontal lines to make it become a box. Okay, then after that, the minimum and maximum value will actually form a whisker from the side. And please take note that your whisker shouldn't cross over or cross through the box. Okay, so if you have the line, the whisker cross through the box, that means it is wrong. Okay, so for this one, basically we need to label out clearly that this set of value is for the, sorry, not female pula, the company A, right? Okay, then now we can continue with company B. So the minimum is 2,540, so you can draw anywhere maybe slightly higher. 2,540, maybe is this one. 2,600 is this. 2,690 will be this one. And then 2,780 is this. Maximum is 3,090. So 3,090 is quite at the back. Okay, so again, the Q1, Q2, Q3, you try to connect them into a box. And then the whisker, you go and connect it with the box, but shouldn't go through it. So label it clearly. This is for company B. Alright, so when you are drawing two box and whisker plot in the single diagram, please make sure a few things here. The first one is make sure that you label the ratio of the scale or the axis clearly, and then don't forget about the unit and also the details for the axis. Okay, then after that, when you draw the two box and whisker plot, please make sure that you label the data clearly. Which one is for company A, which one is for company B. Alright, so all these are important, then you have to make sure that you show it in your solution. Okay, then now let's proceed to part C. Okay, so for part C, they want us to comment whether mean would be a more appropriate measure than the median for the two companies. Okay, if you try to have a look for the two companies, right? Okay, if you want to see clearer from the the box and whisker plot, this is what we have here. You can see that for company A, the distribution for all the salaries are quite okay lah. Okay, they are like quite balanced. So the middle salary one are all they are a lot, quite a lot. Then the higher salary one will be less. Okay, then if you have a look for company B, right? We can see one very obvious value, which is extremely large one, which is very big difference from the other stuff. Okay, which is the 3,090, because other stuff I get 2,000 over, 2,800 over, but you can see there's a huge gap between this and this. All right, so for us, we are going to name this value because it is extremely large. So we'll call this as extreme value. So when you're having any extreme value in a set of data, basically we shouldn't use mean to calculate or to represent the value for the data. Alright, it is because of the extreme value will affect the mean in our calculation. So it is not a good method or good measure for the central tendency. Okay, so for this question, they are asking us to explain. So since we are having the extreme value, right? Therefore, the answer is very obvious where the mean is not a more appropriate method, is not a more appropriate method measure, not method, a measure than the median. Okay, and then if can we try to tell them the reason also. Okay, so why I said that the mean is not suitable, it is because of there's a extreme value. There is an extreme value which is 3090, okay, in company B. Yeah, so this is how we put a simple comment on which measure is more appropriate for the central tendency for these two cell data. All right. Okay, so here we ended our question number 3. So we'll proceed to question number. Okay, we are coming to this question number 4. We have a fair 5-sided spinner and then it has a side label 1, 2, 3, 4, 5. The spinner is spun repeatedly until a 2 is obtained. Until something is obtained, highlight the phrase here. When you have until something is happened or until something appear for the first time and so on, all this kind of question belongs to geometric distribution. Okay, then the random variable x denotes the number of spins required. Okay, so from here, since I know that it is geometric distribution, so I want to know what is the probability for a single throw to obtain a 2. So to obtain a 2 for a single throw, the probability is 1 over 5. Okay, all right, then now they said calculate the probability for x equals to 4. So x equals to 4 means what? Means that the first 2 appear at the 4th throw. Okay, so which means that first throw I didn't get a 2. Therefore, the probability will be 4 over 5. Second throw I also didn't get the 2, so also 4 over 5. Third throw I didn't get a 2, I also get 4 over 5. And the fourth throw here I successfully get the 2, which is 1 over 5, the probability. So the first 3 here is not getting a 2, and then the fourth throw only I get a 2. That means the 2 appear first time on the 4th throw. Okay, right, so to calculate this probability, again, simplify everything, you'll get 64 over 625. Okay, so this is how we solve for part A. Next, let us have a look for part number B. So for part number B, we are having, they want us to calculate the probability for x smaller than 6. Okay, so there's a formula that we can use for a geometric distribution. If I want to find out the probability that x is smaller or equals to r, the shortcut formula can be used is 1 minus q power r. Okay, so this is a formula that we can use. But if you want to apply this formula, you have to ensure that the sign here should be smaller equals to. Okay, and for this question, part number B, they want us to find the probability for x smaller than 6. Therefore, I can change it become x smaller equals to 5 first. Smaller than 6 means doesn't include the 6, right? And geometric distribution is a discrete random variable. Therefore, the previous value for x is 5. So it will be x smaller or equals to 5. Then straight away apply the simple formula here, 1 minus q. Q is 4 over 5, power 5. Okay, so if you are not aware, you have to take note that this 1 over 5 here is a p. So q is 1 minus p. Okay, right, then again, by just pressing the calculator very easily, you can get the answer, which is, the fraction is quite 4 digits. So you're having 2101 divided by 3125. Or if you want, you can change it become 3 significant figure, where it should be 0.672. Okay, so this is how you solve part B for this question. Okay, right, then now let's continue further to part C. Okay, so for part C, now they are saying that I'm having two fair five-sided spinners. So I'm having two spinners now, also labeled 1, 2, 3, 4, 5, plus 1 at the same time. If the numbers obtained are equal, then the score is 0. Otherwise, the score is higher number minus the lower number. Okay, so find the probability that the score is greater than 0, given that the score is not equal to 2. Okay, before I can calculate this probability, right, we are having the event where we have two spinner. Okay, so for the cases are when we are having two spinner or two coins or two dices, to show the complete result, right, one of the method is by using the possibility space diagram. Okay, for me personally, I prefer possibility space diagram because of it can show all the possible result that we have for the question. If we don't want to draw the possibility space diagram, although we can save some time, but your imagination will be very good because you need to make sure that you can remember or you can find out all the possible events, okay, and you won't miss out any possible result. So to me, to be safe, to me personally I feel the possibility space diagram is actually the more convenient way for me to answer this kind of question. Okay, although the setting up time needs some time. Okay, so I'm having dice number 1 or spinner number 1, where the result can be 1, 2, 3, 4, and 5, right? So I will just draw it in the table form, which is a possibility space diagram. Okay, then after that, for this part, I'm having 1, 2, 3, 4, and 5. We're having two spinner, two dice, or two coins, right? All the events that involve two objects that act independently, then you can basically consider this kind of method. Right, so first of all, my result, I'll put it in blue color. So the score is, if I get spinner number 1, 0, spinner number 1 is 1, spinner number 2 is also a 1, right? Then the score will be a 0. Because here they say, if the numbers obtained are equal, then the score is 0. So the blue color is the score. Okay, so when I get 2 and 2 also 0, 3 and 3 also 0, 4 and 4 0, then 5 and 5 also 0. Okay, then after that, if I say the number are different, then the score will be higher number minus the lower number. Okay, so as an example, for this particular cell here, okay, this one, the higher number is a 2, right? Minus 1, you get a 1. So for this cell, the higher number is a 3, right? So 3 minus 1, you get a 2, and so on. So you try to complete the whole table first with all the possible scores. Alright, so like this one is 3 minus 2, you get a 1. So 2 and 3, 1, 2, then 1. Okay, then same thing happen here. 3 minus 2 is a 1, 4 minus 2 is a 2, then 3. Then I'm having 1 and 2, then this one is a 1. Sorry if I didn't draw the table clearly. Okay, so all the blue color one will be actually the scores that I will get. So total you can see that I'm having 25 results, 25 blue color number. Okay, and all the number inside the box in blue color will be the score that we get. Okay, so after this, we will try to answer the question. So for this question, they ask us to find the probability that the score is greater than 0. Score greater than 0, given that the score is not equals to 2. So there are a few important words here. Highlight the keyword given that. Okay, so highlight the keyword given that. This given that tells us that this is a conditional probability. So when I want to write out the symbol, it should be like this. So the score is more than 0, greater than 0. Given that, we will have a slash here, and then not equals to 2. So the score is not equals to 2. Okay, so basically this is a symbol for conditional probability. How I know it's conditional probability? Because of the word given that. Okay, then after that, you want to find out the probability. So the general formula for conditional probability is something like this. If I'm having A intersect B, so the formula will be A given B. So the formula will be A intersect B divided by B. Okay, so I want to apply it in our question here. Okay, so on top, I'm having score greater than 0 intersect with score not equals to 2. Okay, then divided by the probability that the score is not equals to 2. Okay, so we focus on the probability above the fraction first, the numerator. Score greater than 0 but not equals to 2. So maybe you can try to figure out which one fulfill these two events. Score more than 0, score not equals to 2. So all the 0 definitely not correct lah, right? Okay, so 1 also, okay, 1 can be lah, okay? So 1 is the score that is more than 0 but not equals to 2. So 1 is the correct result that I want, one of the result I want. 2, I don't want to accept it because although the 2 is more than 0, but it is not a 2. So 2 should be ignored. Then 3, I should accept it as my result. 4, I should accept it as my result as well. So from here, you can see very clearly that I want to avoid 0 and 2. So if I didn't count in 0 and 2, right? How many numbers or how many highlighted cells that I have if I want to avoid 0 and 2? Okay, so you just try to count the highlighted value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 cells highlighted. So the probability for that fulfill this one, score more than 0, intersect with score not equals to 2 is 14. Out of how many number in total, how many outcome in total? 25. So this is the probability on top. Then now I want to find out how many of the numbers are, how many of the score are not equals to 2. Okay, then of course you need to try and figure out again one by one, but this method, although it's a bit troublesome, but if you compare comparatively, you will realize that it is actually quite safe to use because it actually shows all the result and you won't miss any of it when you want to figure out the result, okay, or maybe the event, the probability. Okay, so maybe I need to correct it first. Sorry, I need to make all the sign disappear first. Okay, I'm having a 3 here. Then this is a 4, right? Okay, then what else do I have? I have to erase all this highlighted part. Okay, so this is 3, this is 4, and this is 3. Then now, for our denominator, we want to find out the probability that the score is not equals to 2. So if the score is not equals to 2, you just need to minus all the score for 2 lah. This one, this one, this one. So there are 6 times of 2 here. So you take 25 minus 6, which is 19, right? So the total probability will be 19 over 25. Okay, so you take 14 over 25 divided by 19 over 25. Then from here, you'll get 14 over 19. Okay, or if you want, you can change it become 3 significant figure again, which is 0.737. Right, so this is how we decide the conditional probability for part C. Okay, so for me, I'm using the possibility space diagram where I feel very secure to be used. Right, although the setting up this table is a bit time consuming, okay, but to me, it actually shows all the possible outcome, which I feel is very, very safe to be used. Right. Okay, then now we continue to part D. Part D. Okay, so for part D, now I have 2 spinners spun at the same time repeatedly, so they always repeat to throw the 2 spinner at the same time. For a 9 randomly chosen spin, okay, of the 2 spinner, find the probability that the score is greater than 2 on at least 3 occasions. Okay, so now you can see that I'm having 9 occasions here, or 9 spins, and then out of the 9 spins, right, at least 3 of them something happened. So when you see this kind of structure of the question, it belongs to binomial distribution. Okay, right, so for binomial distribution, you have to learn how to identify the question itself. There's a specific pattern actually. There's no keyword, but you can see the specific pattern from the question, right? Okay, so before I set out the question, maybe I need to know what is the P in the binomial distribution that I need to find first. So the P is actually this one. The score is greater than 2. Okay, how can I know the probability for the score which is greater than 2? So again, this question is still related to the 2 spinner that we spin just now, right? Okay, therefore the possibility space diagram is useful again. Okay. So maybe I want to paste it here. Right. Okay, so I move my possibility space diagram here. And then let's have a look again. Okay, I want to get the probability that we are having score is more than 2, score greater than 2. Okay, so now maybe I use some other highlighter color lah. Maybe I use a blue color one. Okay, I'm looking for greater than 2 score. So I'm having 3. 3 and 4 are greater than 2, right? So you just highlight them 3 and 4. So how many of them are more than 2? So there are only 6 of them, right? So the probability that the score is more than 2 is actually 6 over 25. And now I want to make it as, I assume that X is the number of spin that has a score greater than 2 is binomial distributed. Total number of chosen spin is 9. And then the probability of one single spin to get the score greater than 2 is 6 over 25. And now they want us to calculate the probability for at least 3 occasions. So X is greater or equals to 3. Got equal sign at least, right? So got equal sign. Okay, so you can calculate the probability from 3, X equals to 3, X equals to 4, until X equals to 9. Okay, to me that is a bit too long, so I will take 1 minus. So I will take 1 minus X equals to 0, 1, and 2. So when X equals to 0, I'm having 9C0, 6 over 25 power 0, and then 19 over 25 power 9. Then I want to minus also XC1. X equals to 1, sorry. So it will be 9C1, 6 over 25 power 1, 19 over 25 power 8. Okay, then I also want to minus X equals to 2, so I'm having 9C2, 6 over 25 power 2, and then 19 over 25 power 7. Okay, and then just use calculator and get the answer. If you didn't do any careless mistake when pressing calculator, the answer that you get should be 0.371, correct to 3 significant figure. Right, so this particular question is a binomial distribution. Okay, all right, so we ended the discussion for question number 4. Okay, we'll proceed to question number 5. So let's discuss question number 5. Okay, so we have the length of western bluebirds are normally distributed. So maybe you can highlight the keyword normally distributed with the mean and also standard deviation, right? We have a random sample of 150 of these birds that is selected, and then how many of the birds you expect to have length between these two values. Okay, so before you can find out the expected number for the birds, right, you have to calculate the probability for the birds with this length first. Then after that, only you multiply with 150. Okay, so since we know that X, maybe we can denote X as the length of the western bluebirds. So they are normally distributed. The mean is 16.5 and the variance is 0.6 square. Okay, and then we want to find the length. Okay, we want to find the probability that the length is between 15.4 and also 16.8. Okay, so since this variable, right, X is normally distributed, therefore, before I want to find out the probability, I have to standardize it become Z first, because they are normally distributed, right? It is normally distributed, therefore you have to standardize it before you can use the standard normal table. Right, so how to standardize it? We are taking the original value of X, then we have to minus the mean divided by standard deviation. So the standard deviation is 0.6. Same thing happened for the other side. I'm having 16.8. So you have to minus the mean, which is minus 16.5, divided by standard deviation, which is 0.6 as well. Okay, and after that, we are going to just get the value for the Z. So correct to 3 decimal places. Alright, so negative 1.833, and then Z, and then 0.5. Okay, so to calculate the probability for Z between these two values, right, there are actually many ways that you can solve it. So for me, usually I'm looking at the normal curve for the Z. And then I know that I'm looking for this one, negative 1.833. And then I'm having a 0.5. Because you need to know Z standard normal table, right? The mean is in the middle, which is 0. So basically I want to find this probability, this area or this probability. And then to find this probability, I need to rephrase my step again. Okay, where I want to find out the probability of this blue color area. So this whole blue color area, right, if I want to write out in a symbol form, right, it should be the probability of z smaller than 0.5. Okay, then to get the shaded area, I actually need to minus the area below this one, which is the green color area. Okay, so you can see that I'm having a blue color area minus the green color area, then I will get the shaded area that I want to find from the question. Therefore, when I want to write the step, it will be z smaller than 0.5 minus z smaller than negative 1.833. Okay, so after you already know your step, then you can start to find out the area that you want to find from the normal distribution table. Okay, so I'm looking for z smaller than z smaller than 0.5. Okay, so where is z smaller than 0.5? You will look for the table, then you look for the value 0.5. Z is 0.5, this one, right? So the value for the probability will be 6915. Okay, so I'm having this 0.6915. Then minus, okay, so for this green color area here, it is equals to the right hand side area, okay, for negative 1.833. So to find out this small area here, you need to take 1 minus, and then z smaller than 1.833. So again, I go back to the table. I am looking for 1.833. So I'm having 1.83, where the value given here is this one. And then I need to add some number at the back, which is a 3 also. Okay, so you see 1.833. So that means you need to add a 2 at the last digit of this 9664. So 9664, you plus 2, you will get 9666, right? Okay, so for this probability, it will be 1 minus 0.9666, so that I can get this small green color area here. Okay, then again, by just pressing the calculator, try to simplify, you have your answer 0.6581. Okay, so after I found the probability, okay, that the bird sound is, the length of the bird is between these two lengths, these two values. Now I want to calculate the expected number. Okay, how many number of the birds are having this length, right? So I'm having 150 birds in total. So to calculate the number of expected birds, I need to take the probability multiplied with 150. So the expected birds will be equals to 150 multiplied with 0.6581. Then I'm having this one, 98.715. But of course, now when we are talking about the number of birds, right, it should be integer. So usually for our marking scheme, they will accept the integer either below or above the number that we get. So like 98.715, right, you can put it as 98 birds or you can put it as 99 birds. Both answers are accepted in marking scheme. Right, so 98 is correct, 99 is also acceptable. Okay, so this is how we answer question number 5A. Alright, so we will proceed to part B. Okay, so for part B, now I'm having the length of eastern bluebirds. Just now one is western. Okay, so now we are having the length of eastern bluebirds are also normally distributed. So please highlight the keyword again. Then they are having this mean and also standard deviation, unknown, standard deviation. It is known that 72% of the eastern bluebirds have length greater than 17.1. Okay, so this particular sentence, actually we can express it in a symbol form. So we are talking about probability, right? And then the eastern bluebirds, let's say I still assume it as x. Okay, now the x become eastern bluebirds already, have length greater than 17.1, greater than 17.1. Okay, and it is actually 72%. So that means that if I convert into a probability, it will be 0.72. Okay, so by translating this particular sentence into a symbol, right, now they want us to find the value of sigma. Okay, So we try to solve this information given in the question, and then throughout the step, you will see that we can find out the sigma value. Okay, so first of all, again, I know that x is normally distributed, and then the mean is 18.4, and standard deviation, I don't know. Okay, so since I am given this information, right, again, when you want to find the probability for a normal distribution variable, you need to change the x become z first. Okay, so how to change it become z? Again, you take the value of x minus the mean, and then divided by standard deviation, and it is equals to 0.72. Okay, so to decide the value of z in this step, right, you need to maybe imagine a graph again. Usually for me, there are many ways to solve this kind of question. Some students, they will like shift the equation, make it here and there, shift it to the left and right, or maybe they take 1 minus and so on. But for me, usually I will straight away draw a diagram that represent this particular step here. Okay, so they said z greater than this particular number is equals to 0.72. So please take note, this 0.72, right, is the area that is more than half of the graph. 0.72 means more than half, right, more than 0.5. Therefore, when I want to sketch this diagram, it actually tells us that I'm having this value of z. And then on the right hand side, greater than z, the area is 0.72. So that means this is 0.72. Okay, so this is 0.72. And then this particular z is actually equals to my value, right, which is 17.1 minus 18.4, then divided by standard deviation. And now I want to find out the value of z from the normal distribution table so that I can compare it with my equation here. Then later I can find out the sigma. Okay, right. Then now how can I find the value of z from the normal distribution table? Okay, so please take note, I'm having 0.72, which is the area. Okay, so I go back to the normal distribution table. 0.72 is the area. Therefore, the value of area we should find out from here. And then the value of z is outside. So you need to do it in a reverse way. That means I want to find out the area 0.72 and get the value of z outside. Okay, right. So let's have a look for the 0.72. Where is 0.72 here? We are trying to choose a number that's closest to the 0.72 but smaller than that, smaller than it. So this one. This is the number that smaller than 0.72 but closest to 0.72. Okay, if you try to read the value of the z, right, so you'll get that it is actually equals to 0.58. And then to make it become 0.72, you need to add, what do you need to add at the back? So you need to add a 10, right? If you add a 10, so you will have 0.72. So let's have a look at the back. Is there any 10 here? Oh, so there's a 10 here. Then if you read out the value for the z, you'll get the 3. So when you simplify all the value here, it will be 0.583. Okay, so remember this value, 0.583. Okay, I go back to my solution here. I know that this value of z is 0.583. But because of, from this particular diagram that you draw just now, right, you already can see that z is on the left hand side of the whole graph, where the middle, the mean is 0. So the value of z here should be actually a negative value. So you should put a negative for the value that you get. So it will be negative 0.583, which means that you are using your value here. This value is equals to negative 0.583. So I'm having 17.1 minus 18.4 divided by standard deviation equals to negative 0.583. Okay, and then you just try to use calculator again to help you on this. You'll get the long value for sigma. 5626. And of course, we will correct it to 3 significant figure where your final answer for sigma should be 2.23. So this is how we solve part B for question number 5. Okay, then after that, we continue to part C. Okay, so for part C, now I'm having a random sample of 120 eastern bluebirds. So eastern one is chosen. Use an approximation, highlight the keyword approximation, to find the probability that fewer than 80 of these 120 bluebirds have length greater than 17.1. Okay, so for this question, the keyword is approximation, right? Okay, so this actually give us a very big hint. In our AS syllabus for stats 1, there's only one type of approximation where the original distribution will be binomial and we will change it become normal distribution. So here you can see that they already give us a very big hint. So the original distribution for x is binomial distributed, and I'm having 120. Okay, 120, which is the n. And I need to put in the value of p as a second parameter here, right? So what is the value of p that I should put in here? So we are looking for the length for the bird greater than 17.1. Okay, and then what is the probability? So if you refer back to the part B just now, they already told you that the length greater than 17.1, right? The probability is 0.72. So that means I can straight away put the 0.72 as the P in my part C. Because I say here greater than 17.1, right? So the P here will be actually 0.72. And this is binomial distribution with the parameter n and p. Because of the word approximation also, then you need to change it become normal distribution. For normal distribution, the first parameter is the mean. How we calculate the mean from binomial? So you take n multiplies with p. N multiplied with p, we will get 86.4. And then for the variance, the second parameter in the normal distribution is variance, right? So for variance, you are taking n times p times q. So if you take n times p times q, basically you have 24.192. Okay, so just to remind you all, this one is n times p, and then this one is n times p times q, where q is 1 minus p. Okay, right. So after you change become normal distribution, then you can start answer the question. They're asking for the probability, right? Asking for probability fewer than 80 of the bluebird. So I'm having number of bluebird is fewer than 80. Okay, the word fewer means doesn't include 80. So you can see that there's no equal sign here. And then has length greater than 17.1. So I want to calculate this probability basically. Okay, then before we can continue, you need to know that, okay, for binomial, it is a discrete random variable. And then for normal, it is a continuous random variable. So when you are changing the discrete to continuous random variable, right, you actually need to make some adjustment for the value of x so that there's no gap between the graph, right? Okay, so for x smaller than 80, when you are trying to apply the continuity correction, it should be smaller than 79.5. Okay, then after that, let us continue with the calculation for the probability. So this is the continuity correction value. So again, now I change it become normal already, right? So to find the probability, I have to change it become z. That means I have to standardize it become z. Again, please show the process of standardizing clearly. So I'm having 79.5 minus the mean, which is 86.4, then divided by standard deviation. This value here is a variance, right? So standard deviation will need to take the square root, then 24.192. Alright, then again, use calculator and help us to get the value of z. So the value of z is negative 1.403, correct, to 3 decimal places. And now I want to find out the area that is z smaller than negative 1.403. Again, I will go to the table. There's no negative value for the z in the table, right? But never mind, we'll try to find out the positive value first. So for the positive 1.403, this is what we have. So this is 1.40. 1.40 is this one. 9192, and then you look for the 3 at the back. So the 3 here is actually you try to add a 4. So 9192, you need to add a 4 at the last digit. Okay, so you get 9196. Okay, so the 0.9196, right, basically refer to the area that's smaller than 1.403. Okay, but I want to get the value or the area that's smaller than negative 1.03403. That means now this is the area that I want to find. So to find this particular area here, because when I reflect it from the left to the right, this is actually the area that I want to find. It's the same. Okay, so to find this particular green color area, I have to take 1 minus the 0.9196 that I get from the table. Okay, so if you try to simplify it, then you'll get 0.0804. Alright, so this is how we answer this question. Okay. Okay, so we are now at the last question for this paper, question number 6. In a group of 25 people, there are 6 swimmers and then 8 cyclists and also 11 runners. Right, so each person competes in only one of these sports. So there's a team of 7 people is selected. Highlight the keyword selected. This basically tells us that it is a combination question where the arrangement of the item or maybe the person is not important. The sequence is not important. All right. So the 7 people is selected from these 25 people to take part in competition. Okay, so for part number A, they want us to find the number of different ways in which a team can be selected. So I want to select 7 people, but there are some restrictions to follow. If it consists of exactly 1 swimmer, so in the team, I can have only 1 swimmer, and then I can have at least 4 cyclists and also at most 2 runners. So for all these kind of cases, it will be good that we can try to arrange out all the possible outcome or possible cases. So maybe I will list out my member as 3 groups. I'm having swimmers, and I'm having cyclists, and I'm having runner, right? Okay, so originally I'm having 6 swimmer, I'm having 8 cyclists, I'm having 11 runners. Okay, so now I want to try to list out all the possible cases to fulfill the restriction listed in the question here. So for the team, a team of 7, I must have only 1 swimmer, so I put it as 1. 4 cyclists and at most 2 runners, right? So at least 4 cyclists, I have 4 cyclists, I have 2 runners. So this is the first case where it fulfills the restriction that they want us to have. Okay, but besides that, I also have second possible cases where I have 1 swimmer. Since they said I should have, it can be at least 4 cyclists, right? So that means I can increase the number of cyclists in the team. So that means besides 4 cyclists, I can increase it as 5. Okay, and then for the runner, since I'm having 5 cyclists and also 1 swimmer already, so I have only 1 more space available for the runner. So runner can be 1. So total still 7. Okay, and then how about for case number 3? So for case number 3, I can have 1 swimmer. Then for the cyclist, I increase 1 more that number for cyclists, which is becomes 6. And then 1 plus 6 becomes 7 already, right? So this value should be a 0. Okay, then if you want to further investigate whether is it possible to have case number 4 or not. So let's say I'm still having 1 swimmer, then I put cyclists as 7 members. So basically you can see that it is already more than or exceed the number of team members that I want. I want only 7. But if you have this case, it becomes 7 plus 1, which is 8. That means this is not the correct case anymore. Okay, so basically I'm having 3 cases here. Alright, so to calculate the number of selection, right, you need to choose the different team member from the different group. So I'm having 6 swimmer. I want to choose 1 only for case number 1. So it will be 6v1. And then multiply with, I have 8 cyclists in total. I want to select 4 of them. So 8c4. Then 11 runners, select 2. So 11c2. Okay, so for this one, if you try to press calculator and get the answer, you will get 23100. First case. And then for the second case, we do the same thing. So 6 swimmer choose 1, 8 cyclists choose 5, and then 11 runners choose 1 only. So for this one, I'm having 3696. Then for the last case here, I'm having 6 swimmer, I want to choose 1, 8 cyclists, I want to choose 6, and then 11 cyclists, 11 runners, sorry, I want to choose 0. So from here, I have only 1, 6, 8. After I find out all the combination for the 3 cases, then you can total them up to get a final answer. Okay, so the final answer for this one should be 26964. So these are the total number of ways that we can select to form a team with 7 members and with this restriction fulfilled. Alright. Okay, so this is what I have for 6A. Let's proceed to 6B. Okay, so for 6B, we have another competition. A team of 9 members consists of 2 swimmers, 3 cyclists, 4 runners. Okay, so total I'm having 9 persons. So the team members stand in a line for the photograph. How many different arrangements are there for the 9 people? Okay, so highlight the keyword arrangement. So this tells us that the question is about permutation, where the arrangement or maybe the sequence is important for the calculation. Alright, so I want to arrange the 9 people, and then the restriction is the swimmers stand together, cyclists stand together, and also the runners stand together. Okay, so if I have swimmers stand together, right? So maybe I'm having swimmer, 2 swimmers here. If I want to make sure that they are standing together, and then I bundle them and make it as 1 unit. Assume that they are 1 unit. They cannot be separated. Okay, then I'm having 3 cyclists to be together also. So I bundle them become 1 unit also, 1 item. Then the 4 runner, I also bundle them become 1 unit. So that means when I want to arrange the team members, right, or the 9 people, at first I have to arrange them according to the bundle first. So I'm having 3 items here, 1, 2, and 3. So when I want to arrange these 3 items, it will be 3 factorial. Okay, then after that, we can consider the arrangement within the group member for the swimmer, the cyclist, and also the runner. So for the swimmer, 2 swimmer, to arrange them, you can have 2 factorial. And then for the cyclists, you're having 3 of them, right? They can exchange their position each other between them. So it'll be 3 factorial. Then for the runner, also the same, you're having 4 factorial. So when you multiply all of them together, you can have the total number of permutation, which is 1728. Right. Then after that, we proceed to part C. Arrangement are there. Highlight the keyword arrangement again. The 9 people, if none of the cyclists stand next to each other. If they want to make sure that there's no cyclists stand next to each other, that means all the cyclists must be separated. Okay, if all the cyclists must be separated, right? How many cyclists do I have? I'm having 3. So these 3 persons must be separated. So when we try to answer this kind of question, what I will do is I will arrange the cyclists at last. So that means I arrange the 6 persons here first, 2 swimmers and 4 runners first. Okay, so I have 2 swimmers and then 4 runners, 1, 2, 3, 4. So I arrange them first. After that, only I place the cyclists inside. Okay, so now let's have a look for this 6 persons here. If I want to arrange 6 persons, it will be 6 factorial. Okay, then now only I want to put in the cyclists. So to put in the cyclists, right, I must slot them in between the spaces available between all these people. Okay, so you can see that how many arrows do I have here? How many empty space I can slot in these 3 persons? So 1, 2, 3, 4, 5, 6, 7. There are 7 available spaces, right, to slot the 3 cyclists inside. So to arrange 3 cyclists inside the 7th space, you can write out as 7p3. Okay, where your answer should be 151200. Okay, so for this question, there's another way for you to interpret the question where, okay, so still the same. I need to arrange the 6 people first who are swimmers and also the runner, right? So I'm having 6 factorial. And after that, for the first cyclist, there are 1, 2, 3, 4, 5, 6, 7, 7 place to be, 7 location to be placed. So it will be 7. So let's say I already put the first cyclist here. So this place is no longer available anymore to place other cyclists in. Okay, then now I want to place the second cyclist. So for the second cyclist, you can see that only remaining 6 location or maybe the position is available for the second cyclist. So you can put it as multiply 6. Let's say I put the C here, the second cyclist here. So this place is no longer available anymore. So for the last cyclist, you can have 1, 2, 3, 4, 5. Okay, so five possible places to place the third cyclist. So multiply with 5, and you realize that the answer that you get is actually the same, which is 151200. Okay. Alright, so this is how we solve all the questions for this paper. Alright, thank you very much for watching this video.